Hello everybody, welcome to this tutorial. My name is Lionel and today we see what interfaces are in Java. Alright, the first thing to understand about an interface is that it is something that specifies what a certain class should be able to do without specifying how it should do it. The point of doing this is to allow abstraction, which is one of the key elements of object-oriented programming. To make it clearer, let's say you had a universal remote which could turn on any piece of electronic equipment. The only thing that this remote would care about is whether the objects are electronic or not. The remote wouldn't care about the type of object. Could be a television, a smart fridge, or a washing machine. The remote wouldn't care about the details of the components. In other words, it wouldn't care about the implementation. Well, to do this, you could define an electronic device interface that all electronic devices would implement. That way, the only thing the remote would check is if the object implements that interface. Let's actually put this exact example into code, and it will all make sense. So first, let's create a universal remote class. The only method this class will have is a turn-on method. Now, what type of object should this method take into parameter? Well, it could take a whole bunch of objects, but as we said, the only thing that matters is the interface. Therefore, that's the type we can use. Of course, we will obviously need to create that interface first. Doing that is simple. You basically define it the same way you would define a class. You just use the interface keyword instead of the class keyword. Now, in that interface, what you specify is what methods the classes that will implement this interface should define. The what is three things: the return type of the method, the name of the method, and the argument the method must take. In our case, we would like all electronic devices to have a turn-on method. This method shouldn't return anything and shouldn't have any parameter. Interface methods are by default abstract and public. You don't need to write these keywords, however, because the Java compiler adds them for you. Now that our interface is ready, we can go back to our universal remote class and add this type as the method parameter. What this means is that this method accepts any object that implements the interface, or in other words, any object that is an electronic device. It is important to understand this is a relation between a class and an interface. Implementing an interface means the class is what the interface specifies. For example, you could have a readable interface that a lot of various things could implement. A book, for example, is a readable, therefore it could implement it. A script or a magazine are also readables, therefore they could also implement it. Note that it is a good practice in Java to name interfaces as adjectives. Some examples are serializable, clonable, iterable, and so on. Now, back in the body of the method, all we want to do is call the turn-on method on the electronic device passed to the method. Now that we have our universal remote class ready, let's create some classes that implement the interface. First, let's create a television class. To implement the interface, we simply use the keyword implement, followed by the name of the interface. We do all this right after the class declaration. Note that the definition of the interface a class implements would come after any class inheritance definition. Now you'll see that our class is underlined in red. If you look at the message, you'll see that Java is basically telling us that our class does not implement all the methods present in the electronic device interface. Therefore, you can really see an interface as a contract. A class that implements it signs a contract stipulating that all the interface methods will be implemented in the class. If not, the class should be declared abstract. Alright, so how to fix this? Well, you can simply click on Implement Methods and click OK. What Java will do is add all the methods to your class. That way, your class is now honoring its contract. You also see the method says override, as it would if you were overriding a parent class method. Okay, now, in our turn-on method, we might want to print a message to the console, like the television turned on. The beauty of this mechanism is that all sorts of different objects could implement the same interface. For example, let's have a washing machine class that also implements it. And the message it would print could be the washing machine turned on. Alright, we have our universal remote class and two classes that implement the electronic device interface. Let's now go in our main method to see how it works. First, let's create a universal remote. Next, let's create a television and the washing machine object. What we could do now is call the turn-on method from the remote on any of these classes. We see that the method accepts these objects because they implemented the electronic device interface, and that is all it really cares about. If we run our program, we see that the methods from each class are called. What would also be possible thanks to this is to create a list of electronic devices, for example, which could really be composed of all sorts of different objects. The only thing they have in common is the fact that they implement the interface. Now that we have a list of electronic devices, we could run a loop on it and turn on every device. The interesting thing to note is that the only method that you will see available in the loop is the turn-on method. The reason behind this is that since the specified type is electronic device, the only method that we can call are the methods present in the electronic device interface. Now, you might be thinking that, well, it's all good and all, but why use this when we could use inheritance and simply inherit from an electronic device class or abstract class in our television and washing machine classes? Well, one of the strengths of inheritance is that classes can implement multiple interfaces, but they cannot inherit from multiple classes. For example, we could have an entertainment device interface, and this interface would be implemented by our television class. To do this, simply add a comma between each interface that should be implemented by the class. Alright, we've seen the core of interfaces theory. Now, let's see some other details and properties about them. First thing to note is that it is possible to add a static attribute to interfaces. For example, our electronic device class could have a programmable boolean set to true. What the compiler automatically adds are the keywords static, public, and final. Now, we could access it through the interface type. These attributes are also inherited. Therefore, we could also access our boolean through the washing machine type, for example. Please note that putting a bunch of constants in an interface is what's called the constant interface pattern, which is a really bad practice. I would recommend different ways of holding constants. You could, for example, have a class declared final that would hold them. Next point is that starting from JDK 8, we can now define default implementations for methods in our interfaces. This is really not a good practice neither, but it is possible to do so. The main reason it can be useful is if you want to add a method to an interface without risking to break your program because 100 classes already implement this interface. By providing a default method, nothing would break, as it wouldn't be mandatory anymore to implement the method. To specify a default implementation, you can add the keyword default in front of your method declaration, and then add its body. Now, if we remove the method implementation in our washing machine class, we see that Java doesn't complain, because a default implementation is provided. Another thing that is possible since the JDK 8 is to define static methods in interfaces, the same way you would do in classes. For example, we could define a static useElectricity method that prints consuming electricity. Now, in our main method, we could access this interface static method without having any instance of an object implementing this interface. One thing to note, however, is that interface static methods are not inherited. We therefore couldn't say washing machine.useElectricity. Next, since the JDK 9 interfaces can declare private methods. These methods are not inherited and can only be used from a default method implementation. A final note is that in Java, there is a thing called a functional interface, which is basically an interface with only one abstract method. This, however, will be part of a video covering Lambda expressions. Alright, in short, remember that interfaces are a way of achieving abstraction by defining a contract that classes must honor. Interfaces specify the what and leave the how to the implementing classes. I really hope I made things clearer. If not, or if you still have questions, feel free to leave them in the comments below. And of course, if it helped, remember to leave a like and subscribe to this channel to be notified of future Java and programming related videos. Alright, that's it. Thanks for watching and see you in the next video.